All right, yeah. So again, thanks everybody for attending this session here. And the focus today is really going to be about how to use and leverage your Wyebot sensors, while you're upgrading your network infrastructure. Okay. So a little bit about myself, right? So I'm the sales engineering manager here at Wyebot, but really, my background is I'm a Wi-Fi engineer, and I've done a lot of work with deployments of networks. That's really where I spent most of my time. I worked for a few MSPs where basically we'd be deploying thousands of access points every week, and so I know a lot about the challenges you see when you're deploying access points and initially getting those systems to function the way you expect them to. Right. So I live in Phoenix, Arizona. So, enjoying the heat right now while it lasts. But anyway, let's kind of get into this. So, upgrading Wi-Fi network, right? That's, something that everybody's doing, periodically. Everybody's got kind of a different interval they use when they upgrade. But there's a few reasons why it can be necessary to do that, right? So in some cases, you actually need new hardware to support newer standards, right? Wi-Fi 6, right? That came out in, I think 2016, right? Now it's pretty popular on the market. So we're definitely seeing more Wi-Fi 6 deployment in the world, but of course, that's going to require new access point hardware, right, to support that. Similarly, WPA3 security, right? In some circumstances, regulations, things like that are telling people they need to get away from WPA2, move on to WPA3, right? And that, again, in some sense, will require a hardware refresh to support those new encryption types and things of that nature. And of course, the 6 gigahertz band, right? So that's a totally new, RF band to the Wi-Fi industry. And again, right, you need new hardware to support those new radios that transmit on these frequencies. So the point being, you will eventually at some point have to upgrade your access points, right? The other reason you have to upgrade is just due to the needs of the network, right? Increased client density. It's very common, as many of you know, for every client on the network to have not just one Wi-Fi device, but multiple Wi-Fi devices, smartwatches, cell phones, laptops, IoT systems, door locks, right? Wireless cameras. I mean, the list goes on. But Wi-Fi is it's really not going away, right? It's becoming more and more popular, and you will need, in some sense, to support that with hardware refreshes, upgrades to the network. But obviously, as we all know, right, that's a very expensive prospect, upgrading your entire Wi-Fi infrastructure. So when you're spending hundreds of thousands, maybe even up to $1 million, depending on the size of your organization, right? It's important to make sure that new equipment you're deploying is operating, right, correctly. So you need to optimize. You need to look at how the network's functioning. Make some changes based on the data that you see, in order to get value for your investment, right? Because nobody likes it when you upgrade a Wi-Fi network and it doesn't improve things, or even worse, right? It functions less well than the previous system. So that's all that's to say, right? It's important to kind of, when you do upgrade, make sure that, you spend some time, dialing things in and getting the most out of your investment. So here's some common challenges that we see when we're talking about deploying a new Wi-Fi network. And it goes from things like deployment issues, which would be, when you deploy an AP, maybe it doesn't behave as expected, right? You see access points that you install, they don't come online, they're not reaching the wireless controller. Also, maybe your design, had a problem, or there's a wall that was thicker than expected, something like that, and you're not getting adequate signal strength, right? So that's the initial deployment, right? Making sure your APs are, talking properly to the wireless controller, as well as providing the coverage that you need to support your your infrastructure. Now, beyond deployment, you have configuration, right? The initial setup of the network, and problems with that. You need to dial in things like channel width. So on your 5 gigahertz and 6 gigahertz radios, you have these options for bonding channels using 40 and 80, 160 megahertz, right? And depending on your environment, right, your channel width the recommended channel width might be different. Okay. Also, if you're running too many SSIDs, a fairly common circumstance you get into is when you're supporting maybe multiple different, equipment integrators, different vendors, and every vendor wants to have their own SSID. Well, there's a problem with that because every SSID is going to add overhead to the channels. Same thing with legacy data rates. In most cases, you don't need to support the very, very old Wi-Fi technology that was, popular in the late 90s, but these days we're no longer there. So we can tell you, and we'll talk about this, why you wouldn't be running these legacy rates. Now, beyond your configuration, you need to make sure your new network is compatible with your existing devices, and also try to iron out any bugs that you might be seeing, with a new deployment. So compatibility issues, what I mean by that, well, there could be authentication problems, right? Maybe you switch to a new Wi-Fi standard or a security standard like WPA3, and you have some legacy devices that just don't support it, at the driver level, right? So we can see that, those are fairly common issues there. Legacy device interoperability, right? Certain devices don't support certain Wi-Fi channels. Maybe they don't even support a certain band, right? There's lots of stuff there that can happen. And then, bugs, right? I mean, every Wi-Fi vendor, I don't care who they are, there's going to be some sort of a bug you might find, especially when you're deploying brand new equipment, right? So it's important to be able to identify those bugs and make sure they're ironed out as soon as possible after the initial, deployment of the network. And another topic, this is a, more of an interesting one and kind of a temporary thing you see sometimes when you're doing a network upgrade where, especially these days with supply chain challenges, right? You might order 1,000 access points and you get them in shipments of 100 access points every month or something because of the supply chain constraints. And what you might decide to do is deploy them as you get them, but that can result in a temporary multi-vendor environment where you're having maybe a Cisco and Aruba AP kind of interoperating in the same area. And, it's important to make sure when you have those two vendors around, you have configuration that matches between them. You address any security risks with different security settings, and roaming, right? Interoperability from one client, from one AP to another. It is possible if it's multiple vendors, but you need to make sure the configurations are, kind of aligned in that sense. All right. So also, I do want to talk about the Wyebot technology, right? Because we're going to talk about how you use the Wyebot sensors to leverage, all this data that they collect and correct these issues. So Wyebot sensors, first of all, they're multi-radio devices. So every sensor inside of it, there are 3 separate Wi-Fi radios. What that allows us to do is we have 2 radios that act as 24/7 passive monitors, which are going to continuously take packet captures, are going to analyze what's going on in those channels. They're also going to do spectrum analysis across the bands that they're monitoring. And then beyond those 2 radios, right, we have a 3rd radio where we're able to actually act as a client and connect to the network, run tests. We also use that radio to scan all the channels and find different APs. So the point being, a multi-radio sensor allows us a lot of capability that, a single radio appliance might not have. Okay. Also, we're totally vendor agnostic, which means you can throw us in any environment, any Wi-Fi vendor, even if it's multiple Wi-Fi vendors, and we can tell you what's going on there. Automated troubleshooting, right? We'll talk about that a little bit more on a different slide. Network testing as well, where we're able to connect to the network to run tests, and also proactive capabilities because we can give you notifications, right? So you can find out very quickly when things are going awry due to our notification system that we have. So to show you the vendor agnostic sense here, well, here's the screenshot of a Wyebot dashboard where we're seeing a list of access points here. And you'll note the vendors, there's a few different ones just in the screenshot. We see an Extreme access point, a Meraki access point, a Technicolor. This is, a lot of, residential ISPs use this vendor for their, home Wi-Fi routers, Ubiquity. Point being, right, we're able to display all these access points in a vendor agnostic view, which shows you the facts of the Wi-Fi, which would be the channels that are being used, the signal strength, the technology types. So very important to know, right? Totally vendor agnostic, which allows us to see, Wi-Fi as a whole, beyond just siloed with one vendor. Automated issue detection, right? Automated troubleshooting. Well, this is a very unique aspect to our technology where, the sensors have AI engines, and what they do is with all the data they're collecting, they process it and give you a list of problems, which is one thing, but we also want to give you a solution to those problems, right? So you're able to see, for example, if you're running legacy data rates, right? This is a common issue. Well, our solution is telling you need to go into your access point configuration and get rid of support for certain data rates. right? So based on the data we have, we give you actionable, suggestions to help you optimize your network very quickly. Within minutes after deploying a sensor, you're able to see this data. Active testing, right? So we have this ability to connect as a network client. We can do this from both the Wi-Fi and the wired interface on the sensor. And that allows us to do a whole variety of different things. It's all completely customizable. We can do things as simple as maybe just pinging some targets. We could do simulated video calls and voice calls, right? We can measure response time to certain websites. Whatever you set up, you can absolutely do that. And we're going to record metrics beyond that, including DHCP, DNS, in Radius server if you're connecting to a Radius network. All these metrics are being measured, so you're able to see if you're getting some sort of delay with your Radius response time, causing some connectivity issues. So yeah, it's really nice to have sensors validate performance with testing there. And then notifications. Just talk about this. This is actually a new feature, or some new features around this were just recently added, where we have what are called notification profiles now. So our previous notification logic would basically alert you whenever a test would fail, and then it would send you another alert if it started to pass, right? And in some sense that was fine, that worked for people. But we do now have this profiles type system where you can say, I only want to get alerted if a test fails 4 times within 24 hours, right? Or 10 times in a row or whatever. It's all customizable here. But we do have this as some built-in alerting for you to get those proactive alerts, when things start to have issues. All right, so I do want to talk about using your Wyebot sensors as well, right? Just so everybody knows the best way to use them. So it's important to understand, our sensor technology is primarily going to be an over-the-air monitoring tool. What that means, right, is you're going to want to have your Wyebot sensors placed in areas ideally near an access point. Now, I know that's not always possible, but if you're actually running cables for the sensors you want to deploy, the best place to put them is within 6 to 8 feet of a busy access point. Just because that's where, if you're running a packet capture, you're going to see the most traffic in the environment. Now, of course, that's not always possible, like I said. So you do just want to have the sensors in areas where the Wi-Fi coverage is good. Now, you don't want to have the sensors in places where, you don't really have good Wi-Fi coverage. So sometimes you see sensors installed in, network closets in the middle of a rack, and there's really no access points in there. And we see a lot of, signal loss just due to things like the metal racks and the thickness of the walls, stuff like that. So you really ideally, you want to have the sensors just in those areas where Wi-Fi is important, where they can see the access points close by, and, can see the most data that way. But something I also want to talk about is a concept we call optimal coverage. So for those of you who have, purchased enough Wyebot sensors or use enough Wyebot sensors to have optimal coverage, what I mean by that is you have one sensor for approximately every 4 to 6 access points. And you would have gone over this, during the sales process to kind of discuss what that means, right? The benefit of having that optimal coverage is you get 24/7 network automated optimization through the entire environment, right? It's really nice to have that because you don't need to go and move your sensors around to those areas where issues start getting reported. You're able to find out about the issues before the end users might even see them, right? So that's a benefit for having optimal coverage. Now, if you just have a handful of sensors, which I'm sure some people do, nothing wrong with that. You're able to take the sensors and move them around to those critical areas, right? And that's what I'd recommend. So if you only have a handful of sensors, place them in those areas where, first of all, you're installing the new access points, or any areas where you've been trying to chase some issues and collect some data from that environment. All right, so let's talk about some of the issues we start seeing, and how we can address them with Wyebot. So back to the deployment issues we talked about earlier, that's the initial deployment of your access points, making sure they all come online, making sure they're operating correctly and managed by the wireless controller, right? Always the initial challenge when you're deploying any network. Now, Wyebot can really help you with that in some ways, right? So one thing we could do, what you're seeing in this screenshot is we can identify access points that are transmitting a recovery SSID. Like here we see a screenshot, I believe this is a ruckus access point, which is receiving power right? It's actually getting powered on, but it's not actually communicating with the management network for the Wi-Fi, which means it has to transmit basically a recovery network. So you can use the Wyebot's visibility into all the neighboring access points to see if you have any of these recovery SSIDs out there. And then, based on the MAC address, stuff like that, you can track it down, make sure your AP is coming online and on the right VLAN, stuff like that. That's one aspect of it. Now also signal strength, right? We talked about that earlier. But just to give you some more feedback on that, so one concept you might hear when you're looking at Wi-Fi designs is something called primary signal strength, secondary signal strength, and in some cases even tertiary signal strength, right? So what I mean by that is, you generally want to have over your whole network. Now, these numbers I put in the slide are really general guidelines, and I would suggest, consulting or looking at the requirements of the Wi-Fi clients you have for what is really needed for your network. But in general, throughout your entire area of Wi-Fi coverage, you don't want it to go below minus 67 dBm for the primary access point. But it's also important to have at least a secondary access point at a maybe 70 dBm, right? Just a few dBm weaker. Now, the reason you want that, well, there's two reasons, right? The first reason is for ensuring smooth roaming operation. So if I'm a client connected to an AP, and well, my primary signal strength is strong, my secondary signal strength's all the way down to like minus 85, right? Well, the problem with that is first of all, if I'm walking away from that primary AP, my signal strength is going to keep going lower and lower. Eventually, I'm going to get to the point where I'm getting a lot of data corruption, a lot of packet loss due to SNR, and my retry rate's going up, things like that. It's going to cause slowdowns. And the roam that actually eventually happens, right? It may not even be technically a roam. It could just be a full disconnection and reconnection to the Wi-Fi because of the signal strength degrading to such a level. So having a strong secondary signal strength allows a device when, the signal drops to whatever that device deems as the roaming threshold. It's different for every device, but it might be like minus 75 dBm. Well, it has another AP it can jump to at a strong signal strength already available, right? So that's very important for roaming. Now, the other reason you want to have good secondary coverage for signal strength is redundancy, right? So if you have an access point go offline, which certainly can happen, maybe there's a problem with a cable, or there's water damage, or whatever, right? It's good to have at least a secondary AP that can jump in and provide at least temporarily some adequate coverage for that area. So that's kind of the concept there. And then you may want to go further with tertiary signal strength, stuff like that. The point being, though, if I look at this table down here below, this is I actually have a Wyebot sensor in my house, which is a pretty small townhouse. So I have two APs. They're both at very strong signal strength, minus 28, minus 35, right? So I mean, it's a little ridiculous here what I have. It's not probably what you'd normally see in a real environment, but you can use this view, this access points list, which you can see on your Wyebot sensors by clicking on the access points tile. It'll expand this interface here. The list of all the access points in the signal strengths reported from those access points, and from the perspective of the sensor, rather. Which means you take a sensor, you stick it in an area, maybe if you're a school, it's a classroom, and you want to see like the closest AP is very strong, the second one's at minus 70, right? Okay, well, that's fine, right? Or maybe it's not that, and you need to kind of look at your design, maybe look at transmit powers, things like that to get that in line. But basically, you have this data at your disposal during that initial deployment to help you understand if your APs are actually providing the coverage that you need in all the areas you have these sensors deployed. All right, so that's the deployment, main stuff there. But I also want to talk about configuration, right? And this is always a little bit more complex because obviously now you're getting into the different settings you have at your wireless controller, and of course it's different depending on your network requirements. But just to talk about some quick bullet points here. One thing I would say is, default settings from your Wi-Fi vendor are not going to always be optimal for your environment, right? I'm sure many of you know this, but we do see a lot of deployments where, maybe the default settings are leveraged a little bit more than they probably should be. Okay, so just wanted to bring that up. Now, you also might have unexpected behavior. So what do I mean by that? Well, maybe you make a configuration change and it doesn't do what you think it does, right? We've seen it before where you change a setting, like, I don't know, the you get rid of some data rates, and then you find out your AP is no longer supporting like some certain Wi-Fi standard that you need, right? So the point is, that can happen, right? You can make a change and it doesn't do what you think it does. So having data around that is very useful. And then of course, it's very important to optimize for your environment, right? As much as I'd like to say there's one Wi-Fi config everybody should use, yeah, sure, there's some general best practice guidelines, right? But when you're really getting down into the weeds, every environment is going to be a little bit different with what you should be doing. So it's important to use a data-driven approach when you're configuring your network to make sure it's optimized for that environment. So here's some common mistakes we see. And this is some evidence of the Wyebot sensor actually identifying those mistakes. So here's a classic, right? Supporting some unneeded legacy Wi-Fi standards. Okay, well, what do I mean? Really, I'm just talking about 802.11b, okay? Now, for those that know, that's basically the first Wi-Fi standard that really was on the market for consumers to use. And we're talking late 90s, right? Late 90s, maybe early 2000s. And what you'd have to do back then, if you recall, right, is you had a laptop, like a giant, ThinkPad, right? And you took a PCM card and you put that in the laptop, and that's how it would be able to connect to Wi-Fi. Well, we don't do that anymore, right? You haven't seen that, and I would hope a long time. So this tech's been outdated for about 20 years now, right? 802.11g was 2003 or 2004. I don't remember exactly the year, but that technology came out and it essentially replaced B. It's so what we see though all the time is, even brand new Wi-Fi 6E, 6 gigahertz access points. Well, on their 2.4 radios, they're still supporting the B standard. Now they do that because they want to be backwards compatible. So if one of their, if an Aruba customer happened to have this really old device and it wasn't able to connect to the Wi-Fi anymore after they installed the APs, well, they might say Aruba APs aren't any good. So Aruba says, well, let's just go ahead and support these standards just in case our customers need them. But, right, when you're looking at your network, I can almost guarantee you that 90% of the environments we look at don't need support for 802.11b. So if you see that turned on, Wyebot's going to detect it for you with one of our issues in that problem and solution list we looked at earlier. And the solution explains, right? It's going to cause a lot more airtime use. You're supporting 1 megabit per second transmissions. That's never good on Wi-Fi to support very slow speed transmissions if you can avoid it. So we're kind of suggesting here to remove support for these data rates on your wireless controller. So that's just one example. Another example we see is, again, going back to channel widths. So I talked about that a little bit earlier. Super common to see this where, you deploy a bunch of access points and you use a channel width. Now there is some desire to use wider channel widths. The reason for that is, if I'm on an 80 megahertz AP, well, I do technically get much faster speeds if I go to speedtest.net, run a speed test. Well, I might get 400 megabits per second, which is crazy, right? It's great. But the downside of that is every access point using an 80 megahertz channel is consuming more of the spectrum, right? And the way that really works under the hood is the base channel width is 20 megahertz, right? So with 80 megahertz, what you're doing is you're combining 4 channels essentially together into one access points radio. And the downside of that, of course, is when you have 100 APs in a building, right? Well, unfortunately, there's just not enough channels for that. There's only 25 available channels on 20 megahertz. So when you use 80 megahertz, you cut yourself down to 6 channels, right? So what we would recommend is basically just not using 80 megahertz. It's pretty easy to recommend that globally. I mean, maybe there's a case somewhere for it, but in most environments, you don't want to run 80 megahertz. 20 and 40 megahertz is what you're going to want to be looking at. And Wyebot can really help you optimize. So here's an example for this. We see a screenshot of an alert saying that we have, some access points here that are using 80 megahertz channel width. Well, there's only 6 channels available, right? So we're saying, in this environment, it makes sense to use 40 megahertz channels because what that's going to do is double the number of channels available, and it's going to help you avoid channel overlap, right? And that's a real killer for Wi-Fi performance, having multiple APs on the same channel. So that's kind of the guidance we're going to give you. And like I said, this is going to be different for everybody's environment. If you're, maybe in an office where you have, 10 access points, right? Well, in that case, you probably want to use 40 megahertz because you have 12 channels and you can have every AP on a different channel. If you're in a school, right? And there's 60 access points in the building. Well, in that case, you probably want to do 20 megahertz channel width because you're going to get the most number of channels available. Yes, you'll sacrifice some top level speed, but right, speed on Wi-Fi is overrated in my opinion. You don't need to have super high speed test results. What you want is consistent, stable performance. And, for 99% of what clients are doing, they're browsing the internet, they're maybe watching videos, even doing video calls or live streams. I mean, nothing really is going to exceed like 10 megabits per second, right? So there's no real need to be able to run a speed test on an AP and get 400 megs. It's not really necessary for an enterprise in most cases. And then, the too many SSIDs, right? So I talked about that earlier. So this is it's getting more well known in the industry, I'd say, but basically every SSID you add has overhead implications because of something called beacon frames. So when I advertise an SSID, it needs to kind of send out a frame. Now, these frames are typically, unless you change the setting, they're by default going to be sent 10 times a second. So multiply that times the number of SSIDs you have. As you can imagine, that starts to use a lot of the bandwidth on the channel, especially if you're running low data rates, because the other problem with this is all beacon frames, all SSID advertisements. Those are always sent at the slowest speed that your AP is configured to support. So what that means is if I'm running legacy 82.11b data rates, I support 1 megabits per second as my basic slowest data rate. Well, what that means is all of my beacons are sent at 1 megabit per second, and they take a long time to get transmitted at that data rate, right? So every SSID adds the overhead. That includes hidden SSIDs as well. So if you hide an SSID, I know it might not seem like it does, but it still has to advertise itself 10 times a second. So this Wyebot sensor will detect that as an issue. It'll give you some guidance. Now, we normally recommend 4 as kind of the baseline for the maximum number of SSIDs. So if you can, try to pare it down, right? And use the Wyebot sensor to kind of expose that as an issue for you and help you address it. And then I think this is the last one, or a couple more, right? So unexpected AP behavior. So going back to that thing I mentioned earlier about you making a change and doing something different than you expect. I have seen, in some cases with certain, wireless vendors, they give you all these different options in the wireless controller. And sometimes, to be honest, they're not very well documented what they do, right? And I have seen it where, maybe you made a change at some point thinking it was required for compatibility on the network, or, it was going to fix some issue, this or that. But really what it might have done is caused issues. So here we see an access point. This is a new, relatively modern N or AC access point, which should support pretty high speeds, but it's actually limiting itself down to the 802.11g standard because there's a setting called WMM, wireless quality of service, really buried in the controller that was disabled. And that actually, maybe unknown to most people, limits your technology down to 802.11g, which is going to really kill the data rates you get on those APs. So it's just one example. I mean, there's lots and lots of different examples you might see of this, but the point being is when you make changes on your wireless controller, the Wyebot sensor is going to always keep reanalyzing the environment and showing you what's going on. And if you see something on here you didn't expect to see, I mean, that can really help you understand, like, oh yeah, maybe I need to go back and take a look at that config that I made. And then last thing here, I think, yes, last thing on config. You can tell I really rehearsed this quite a lot. So one common issue we see is basically, a client tries to connect to an AP, but they can't get access to the internet. They can't go anywhere. Well, one example for that would be your VLAN on your switch port, right? A common configuration is to have every SSID go to a different VLAN, and maybe that VLAN didn't make it to the switch. Well, what happens then is you can connect to the Wi-Fi just fine. You succeed the wireless connection, but you can't get an IP address, right? So having the Wyebot sensors run this testing where they're actually acting as Wi-Fi clients can reveal that for you. We'll connect, and then if it doesn't work, we tell you why. So in this case, we see it says result, can't get IP address, right? So that should be pretty clear to you, like, okay, well, I need to look at what's going on with my AP on the switch because more often than not, that's just because there's a VLAN that didn't make it to the switch port. And trust me, I've done that many times when deploying networks. So no shame in having that issue, but this can help you identify it. All right, so I should also mention, the sensor, everything we've been talking about, all these different, points and data, all that stuff, you don't have to be logged into the sensor waiting for things to occur and hoping to catch it live while you're looking at it, because we keep all of our data historically. So what that means is you get a full, 30-day window through all the different points of data on the sensor, the list of issues, you can see all those in the past, airtime utilization, test results, right? You have historical data that you can look through, which really allows you in some sense to go back in time and identify issues that had happened in the past, which is, I think, as you might be able to imagine, very useful, because mostly with Wi-Fi complaints, or Wi-Fi problems, it's, somebody complains that the Wi-Fi didn't work, and then by the time you're over there testing it, it works fine, right? That's, tale as old as time, essentially, with IT in general. So having historical data is certainly can be necessary there. All right, so let's talk a little bit about some compatibility problems we see, when we're talking about new network deployments. And Wyebot will flag some of these for you to give you some guidance. So here we see an example of a potential security compatibility issue. In this case, we have this uncommon security type alert. What it's saying basically is the reason is, we have the fast transition turned on, and legacy clients, unfortunately, might not be able to support that. Right. So we'll flag for you any kind of something you might want to be aware of. Now, certainly you don't need to address this. If this is an intentional configuration because your clients are going to support it, great. You can always hide these alerts. But having this guidance can really help you understand if there is something out there that might be potentially causing issues. Going further than that, we can actually give you evidence of those issues occurring. One example might be a client that fails to get authenticated if you're running like 82.1x. So here we see, this is my home lab. I have a desktop. I am not very skilled with my Active Directory configuration, and I can't figure out how to get it to authenticate with certificate-based authentication. So we see it failing, right? So it connected, it failed, right? And the Wyebot sensor actually flagged that for me. And it says username was rejected by the authentication server. Verify that it's allowed, right? So I went and checked my logs, and I kind of found out that one of my NPS rules was kind of, causing problems here, right? So we do give you evidence, right, of when these issues are occurring. We catch them intermittently, doesn't matter, right? We have this ability to do these packet captures and identify these little events that come and go. And then further than that, if you're working with an individual client, or there's a specific device you're needing to get connected and it's not connecting, whatever the case may be, we have this tool on the dashboard. It's called device forensics. So if you ever see a magnifying glass on the dashboard on the left-hand side, there's a tab for it even called device forensics. And what this allows you to do is investigate individual users. Here we see this desktop that I was looking at earlier. And we can identify, some of the issues that would be affecting it. Now, we also see info about the client. We know it's an AC radio. We see it's not currently online, but we did down here see this historical chart. Now, back to the historical data, you get 30 days of data per client. So if I look at this client, I could see anytime it had an authentication failure, a de-authentication where it get kicked off the Wi-Fi, maybe it had a high retry percentage. I mean, there's hundreds of different things we might point out depending on what's going on. But the point of this is you're able to investigate individual users, individual clients, and make sure that they're able to connect, to your new Wi-Fi equipment that you're deploying, right? And then also, let's talk about bugs, right? Wi-Fi bugs, things like that. Well, to be honest, this is something where, usually it ends up being a attack case, right? So if you're working with Aruba TAC, Cisco TAC, whatever, TAC, everybody's got a TAC, right? And there's something that just doesn't make any sense to really anybody involved. Well, you go far enough down the rabbit hole and that stuff, you may get a request for a packet capture, right? Specifically a Wi-Fi packet capture. Now, those on this call who have done Wi-Fi packet captures might know that they tend to be rather challenging to even get. And the reason for that is, well, first of all, if you're doing it with a laptop, you normally have to have a special adapter. MacBooks, I think, could do it natively, but Windows, you actually have to have a special Wi-Fi adapter that supports promiscuous mode and a whole bunch of stuff. Plus, you need to be there on site, right? You have to be there running these packet captures, collecting data. Now, you can, in some cases, do it with your access points, with your wireless controller. You could turn an AP into monitor mode, initiate a packet capture, take a look at some data. But Of course, the problem there is when an AP is in monitor mode, it can't really serve as clients. It's kind of busy, listening. It's busy taking packet captures. And also, again, right, that's a initiated process on your end, meaning you have to kind of start a packet capture, wait for something to happen. Well, the Wyebot sensors have a historical packet capture download tool, which is very unique. I mean, so the way that this works is every sensor, as I said earlier, they have 3 Wi-Fi radios. Now, 24/7, when you deploy a sensor, it's actually taking these packet captures. Now, what we do with them is they're actually written to the internal storage onboard the sensors themselves, onboard the units. What that allows for is the ability for you to, on the dashboard, there's an advanced section you'll see, and you'll see a tab that says trace download. Now, what you're able to do from that is retrieve a download from any of the 3 radios on the sensor. So here we see a screenshot of this. And you see the start time, which is in the past, right? So we see an available start time of, in this case, back to April 29th. Now, you don't know when I took the screenshot, but you have to believe me, I took it yesterday, right? So this sensor has like over a month of packet capture data on board. And then you can see, actually, there is evidence, right? 6/27, that's when I took the screenshot. So you do have like, I guess it's almost 2 months of packet capture, which is kind of crazy when you think about it. But you're able to actually go back in time. So when you had like a, intermittent issue, a bug, whatever it is, you need to get some evidence of that. It's much easier to do it in a historical method rather than kind of initiating that capture. So just FYI, that's built into all of your sensors. Now, one thing I will say, just so people are aware, by default, you're going to get roughly 24 hours of packet capture storage within the sensor because we store them just on the RAM on the units by default. Okay, but if you do end up using this feature a lot and it's something you're interested in, we actually offer an upgrade for the storage in the form of a USB dongle that you plug into the sensor. And that will take your packet capture storage well beyond what you see, by default. In this case, like we see here, almost, 2 months, right? So that is a just FYI for you. If that's something you're interested in, you can always email us at customer success@wyebot.com, and they can talk to you about the options for that. All right, so multi-vendor coexistence, right? This is one of those topics I alluded to earlier that is can be really complicated, right, to actually get working. But like I said, sometimes you have a temporary multi-vendor network because of supply chain issues, and you just need to put the APs up as you get them. You really don't have a choice. And again, it's possible to do that. It's possible to have a Wi-Fi network with multiple vendors and the same SSIDs configured between them and have it work. But there are some challenges around that, right? Making sure your configurations match, right? Making sure you have the same channel widths and the same security config, all that stuff. And optimizing for smooth interoperability and roaming, right? Very, very challenging, but it is possible. And Wyebot is a great tool for that because, like we said earlier, we're completely vendor agnostic. So you can put us right in the middle of your whole multi-vendor environment there, and we'll see what's going on between all those different APs and give you some advice when it's relevant. So some examples of this, right? We have APs that have, well, here's a case down here, the screenshot, right? APs with mismatched channel widths, right? So here we see there's a few different APs. Now we have some on 40 megahertz, some on 80 megahertz. And, we're kind of explaining, if you have different channel width on different access points, you're going to have a lot of variance in the experience as, a device or a client walks around the network. A client might even refuse to connect to an AP because it's at maybe a more narrow channel width than the one it's currently on, right? So it's important to make sure you have that all lined up between every Wi-Fi controller in the area. And I didn't grab a screenshot of this, but also another issue we do see is mismatched security settings. So if you have, and again, this is saying you have the same SSID on multiple vendors. Well, one vendor might be using, WPA2, and the other vendor you might not have realized it defaulted to WPA3. Well, the problem with that is you really can't roam between those two because the security exchange that would normally happen it's not as smooth of a process when you have those mismatches in configuration. So the devices don't smoothly roam. They have to actually fully, re-authenticate. And that could be certainly problematic. And then you can have like issues with, legacy security turned on, or even access points that are operating on insecure standards like, WEP, and you didn't even realize that. Well, that's a security risk because you have one AP somebody can get into and, crack the key on, and then, you have a whole can of worms there with, with a hole open in the network there. So just some examples of some common multi-vendor issues that, again, Wyebot is able to help expose for you. So let's talk a little bit about the network test a little bit, where you can validate the performance of your network after you get everything kind of dialed in and configured. So as I said earlier, right, Wyebot can act as a network client on either the Wi-Fi or the wired, or of course both. And all these tests that you can do are completely customizable. There's a network test tab you'll see on your dashboard where you can set up really as many tests as you want, and you can have them, do whatever it is that you think is necessary. So that's things like, speed tests. You want to make sure the throughput's good, application test to measure website response time, video conferencing, voice simulation, right? So lots of options around that, including our link doctor test, right? Which I'll show you in a second. But anyway, here we see a screenshot of a historical test graph. I think this is a DNS test. So I'm testing both my DNS servers here. We see it's been pretty quiet lately, but in the past, I guess late in May, we saw some problems there. A lot of high response time, a lot of red, orange dots, which indicate some failures. So having this historical viewpoint of the test results really allows you to analyze your network and kind of look at those trends, right? Make sure your changes that you're making are positive and not causing issues. So here's just to talk about this other function we have. Now, this is with our link doctor test. Now, this test is designed to do all these different quality metrics. Just to talk through what they are, it's very simple. It's pinging the gateway, pinging your DNS, pinging a public IP to make sure you have internet access, resolving a host name, make sure DNS actually works, and pinging that host name. So very simple steps, right? But the point is, if that test fails on one of those steps, it can help you understand, well, where is my network having a problem? Oh, it's my internet connection, right? Or, oh, it's my DNS server, right? So it's really, built to do that basic troubleshooting for you. Now, there's a multi-AP function with this test, which is very, very unique to the Wyebot technology, where you can actually have every sensor test up to 6 access points. What I mean by that is the test will do a round robin logic where each time the test runs on each iteration, it's going to try to test a different AP, up to the 6 closest ones. And the value there is that you're able to determine if you have one AP that is, failing the test and the other ones aren't, right? Cabling issues might be happening, things like that really, they occur, right? But they're hard to diagnose if you have just one AP and the other ones all around them are working, because, clients are just going to say, oh, that AP doesn't work, I'll connect to a different one, right? So this is a good way to really validate what's going on with your performance there. And then, back to notifications, right? So all these tests have these customizable thresholds now where you can set your alerting logic. If you want to get alerted if a test fails so many times in a row, or a certain number of times in a time range. So just let you know, this is under our new notification profiles feature. We're going to do a webinar pretty soon talking about these new features in more detail. But I was sharing the new stuff because it's important to know, right? The Wyebot technology, the Wyebot platform it's not stagnant. We try to update it, at least 4 times a year, give or take, adding new features, and largely over customer feedback, right? So use the gift box you'll see on the top right of your dashboard to submit feature requests. That is something we can definitely talk about here in the Q&A section, which I think is, the next slide. I guessed right. All right, so I did kind of run through the slides I wanted to talk about as far as, the main topics of the presentation, but of course, I'm sure there may be some questions now. So I'm going to turn it over to Adam, who is going to kind of host the Q&A